If all are squares of different areas, find the area of the blue region. Properties of square, right triangle, line constructions. Pythagoras' theorem, trigonometric identities, basic arithmetic and algebraic processes are used to solve this question. Since all the shapes are different squares, the side length of green square and red square are square root of 3 and 3, respectively. Label points Q, D, B, and C. Join line D, B. From right triangle DBC, let angle DCB be equals to theta. Using Pythagoras' theorem in triangle DBC, the square of line CD equals the sum of the square of line BD and the square of line BC. Substitute values and we have that the square of line CD equals 24. After substitution and simplification of values, take the square root of the equation. It follows that line CD equals the square root of 24, which equals to 2 times the square root of 6. From right triangle DBC, line BD divided by line CD equals the sum of 3 and the square root of 3, all divided by 2 times the square root of 6, which equals to sine theta. We call it equation 1. Also, line BC divided by line CD equals 3 minus the square root of 3, all divided by 2 times the square root of 6, which equals to cosine theta. We call it equation 2. Label points G, E, and J. Join line CJ and let it be X. Notice that angle GC equals 90 degrees minus theta and angle JCG equals 45 degrees. This implies that angle ECJ equals theta minus 45 degrees. Also, line CD equals line CE, which equals to 2 times the square root of 6. The reason is that opposite side lengths of a square are equal. Consider right triangle JEC. Line CE divided by X equals cosine theta minus 45 degrees, which equals to 2 times the square root of 6, all divided by X. We call it equation 3. By trigonometric identity, cosine theta minus 45 degrees equals the product of cosine theta and cosine 45 degrees plus the product of sine theta and sine 45 degrees, which equals to the sum of sine theta and cosine theta, all divided by the square root of 2. Substitute into equation 3. We have that 2 times the square root of 6, all divided by x equals the sum of sine theta and cosine theta, all divided by the square root of 2. Substitute equation 1 and equation 2 into equation 3. This implies that 2 times the square root of 6, all divided by x equals the sum of 3 and the square root of 3, all divided by 2 times the square root of 6 plus 3 minus the square root of 3, all divided by 2 times the square root of 6. Divide all the numerator values by the square root of 2. Cross multiply. It implies that 2 times the square root of 2 multiply by the square root of 6, all divided by x equals 3 plus the square root of 3 minus the square root of 3, all divided by 2 times the square root of 6. Cross multiply the second time and simplify. X equals 4 times the square root of 2, as shown on the screen. Since line CG equals line GJ, it is because side lengths of a square are equal. Using Pythagoras' theorem, the square of x equals 2 times the square of line CG. Divide the equation by 2. We have that the square of line CG equals half the square of x, which equals to half of the square of 4 times the square root of 2. The final result is equals to 16 square units. Therefore, the area of the blue region equals the square of length of line CG, which is equals 16 square units.